This is 12.2 of algebra. So a frequency, if I asked you with what frequency do you go to the grocery store, or if you frequent a certain place, we're talking about how many times you go there, okay? So we're going to work with frequency tables, which shows how many times something happens. So in this table here, it's talking about number of home runs at a home run derby and how many of them happen. So there's 4 people that hit home runs of either 2 to 5, okay? And this one, there's 3 people that hit 14 to 17 home runs. So we're going to use this same data, but we're going to make a frequency table that uses intervals of 5. Okay, so we have home runs and frequency. So there's 2 different ways you can write it, okay? So our smallest number is 2, so that's what we're going to start with. To figure out what that goes through, you can count on your hand. So 2, 3, 4, 5, 6. The other way to look at it is every first number, that's what you're going to add 5 between. So 2 plus 5 is 7. 7 plus 5 is 12. 12 plus 5 is 17. I think that's going to be enough. So 7, if this one starts with 12, this one's going to go to 11. This one starts with 17, this one's going to go to 16. This one you have to count on your hand again. So 17, 18, 19, 20, 21. So I'm going to go through this data. I'm going to cross it off. So we're looking for numbers that are between 2 and 6. So there's 1, 2, 3, 4 of them. And then numbers that are between 7 and 11. So there's 1, 2, 3, 4, 5. And then numbers that are between 12 and 16. That's 1, 2, 3, 4. And then numbers that are between 17 and 21, there's just one of those. So your interval is going to change sort of your perspective on it. I mean, it's still pretty similar, but it will change it a little bit. So when you aren't given an interval, you need to make the decision of how much should you do. Clearly on this one, I wouldn't make intervals of like 20, right? That wouldn't make sense. Everything would be in one interval. So, and then making a histogram. So once you've made a frequency table, you can make a histogram, which is a visual way to display it. Okay, so we're going to use this data down at the bottom. Our smallest number is an 80, and our biggest number is 105. I think I'm going to go up by, let's think, by 5 or 6 maybe. Let's try going up by 6, okay? So this is talking about times for a race, okay? So time, I guess times maybe, and frequency. So we said our smallest was 80, and I'm going to go up by 6s, so I'm going to make this 86. And then 86 plus 6 is 92. 92 plus 6, that's 98. 98 plus 6, that's 104. 104 plus 6. Oh, I don't need to add that, right? My highest number is 105, and that'll be caught in there. So this goes to, well, if this is 86, this has to be 85. If this is 92, this has to be 91. Right, so that's 97. 103, and then I gotta count for this one. So 104, 105, 106, 107, 108, 109. The other way I suppose you could do it is say the next category would be 110, right? So that has to be 109, especially if you're working with big intervals. Okay, and then I'm going to have to count my data and hopefully get all the numbers in the right spots. So 80 to 85, there's 1, 2, 3, 4. So we can put in a 4 there. And then I'm looking 86 to 91. 86 to 91. Well, there's 90, so there's 1. There's 2, 3. I think just 3 of them. Then 92 to 97. 92 to 97. So 1, 2. Just 2 of them. 98 to 103. That's 1, 2, 3. And then 104 to 109, there's just that 105, so just 1 of them. Okay, now I'm going to make my histogram, okay? Important with histograms that you, just as I draw a horrible line, that you make your scale the same, okay? You don't want to make it show the data incorrectly, right? If you all of a sudden make a big gap between 3 and 4, then it's going to make it look like there's a lot bigger difference. So I have 1, 2, 3, 4, 5 chunks, and I'm labeling the actual space, not the line. So this is going to be 80 to 85, right? You see how I'm doing that? I'm going to try to make these even as much as I can. 86 to 91, and then 92 to 97. And then 98 to 103, and 104 to 109. So those are the times. And on the left I'll have the frequency. The highest my frequency get is 4. So 1, 2, 3, 4. Okay. So our first one goes all the way up to 4. Our next one goes up to 3. Next one goes up to 2. Next one goes up to 3. Oh, see, that was a little off. It's about right. And my last one goes up to 1. So on the iPad, it's a little hard to draw this, but you get the idea, right? And so, yes, we could see our data in our frequency table, but this is a more visual way to see our data. So, 3 keywords we use when we're looking and describing histograms, okay? Uniform, when all the heights are about the same. Symmetric, which is where if you put a line down the middle, they look like the same on either side, right? Just like a butterfly or your face. If you put a line down the middle, it looks like the same on both sides. And the last one is skewed, when the center isn't where the peak is. It's kind of shifted to one side. So, let's not do our got it problem. Let's just look at these. So if we look at this one, it looks like if I draw a line down the middle, they're the same on both sides. So I would say that this one's symmetric. Okay, this one clearly is skewed, right? It's not symmetric, it's not uniform, it's skewed. Sometimes you might have troubles deciding between 2 words, and that's okay. It often depends on your interval, what word you're going to put with it, okay? So your answer might not be the same as the person next to you. I mean, there are some cases where it's very obvious, like these 2 are very obvious cases, and you should get symmetric and then skewed. Some cases it could go either way. So a cumulative frequency table, okay? You make a regular frequency table, and then you add this extra column, okay? And what this tells you, so this 14 right here, means that there were people that sent 10 to 19 texts and 0 to 9 texts, okay? So it's including everyone. That's either there were people that went from 0 to 9 texts or 10 to 19 texts. I don't think this data is super accurate to how our students text, but anyway. So when you look at this number here, right? So this first number tells us there are 3 people that text 20 to 29 text messages. This 17 tells us there are 17 people that send 20 to 29 text messages or fewer. Okay, it's including everyone in here for the 17. So let's use the data down below to make a cumulative frequency table. So our smallest number is 0, and our biggest number is 15. So let's go up by, how about just 5s? Does that sound good? So I'm going to clear a little bit more room down here. And they don't give us a label for what these numbers are for, so I'm just going to label my first column data. And I'm going to have frequency, and then cumulative frequency. Okay, so we're going to start with 0. We'll go up by 5, so this is 0, 5, 10, 15. Oh, that's all I need. Let's go keep going. So then this is a 4, this is a 9, this is a 14, 15, 16, 17, 18, 19. Okay, let me draw my lines across. Made it maybe a little too squished, but we'll be okay. So first I need to look for numbers that are between 0 and 4. So there's 1, 2, 3, 4, 5, 6. Then numbers that are between 5 and 9. 1, 2, 3, 4. Okay, that's also 4. Then numbers that are between 10 and 14. So 1, 2, 3, 4. And then between 15 and 19, 1, 2. Okay, so that's a frequency table, just what we did. Now we're going to add in the part that makes it a cumulative frequency. So when I'm looking at the 0 to 4 group, there's no one before it. So the cumulative frequency is just 6. It's kind of like you're keeping a running total of every group. Okay. So in my next group, the 5 to 9, we said there's 4 pieces of data. So then for my cumulative frequency, I'm going to do 4 plus this number right here. So 4 plus 6, which is 10. So that's telling me there are 10 pieces of data that are between 5 and 9 or smaller. Okay, so this next one, I'm going to take this 4 and add this 10. So I take this 4, this 10, which gives me 14. So that means that there are 14 pieces of data that are either between 10 and 14 or smaller. And lastly, I take the 2 and I add the 14, which gives me 16, and that should be my total number of pieces of data, right? Because it's including every single group. And there's your homework.